My name is Om Narasimhan. I'm the CEO of Blue Hat Soft. We are a company specializing in two different verticals, one embedded systems and the second one enterprise networking. The objective of this presentation and the demo is to introduce a line of products we designed and implemented aimed at high-end Ethernet equipment testing space. PktPump is an Ethernet packet crafter and a traffic generator for high-speed Ethernet, supporting 10 Gbps, 25 Gbps, and 40 Gbps line rates, or with 64-octet packet size. PktPump is a solution with dedicated hardware component to generate sustained line-speed Ethernet traffic. The product line comprises of three different offerings, each serving a different bandwidth segment. The different products are one dual-ported 10 Gbps traffic generator, a single-ported 25 Gbps traffic generator, a single-ported 40 Gbps traffic generator. The part of the software stack, the front end, is based on Ostinato. Ostinato is an open source software Ethernet packet crafter and traffic generator. There are three main components to PktPump, namely the GUI frontend. This is also called the controller. The controller, as the name implies, lets the user craft different types of packets, start and stop traffic generation, and to do another management task. The controller connects the server process, which runs on the backend hardware hosting computer and interacts with both hardware as well as the GUI frontend. The This component is called drone. There is a driver component as well in the software stack that lets the drone interact with the hardware backend. The traffic generation hardware is based on Marvell, KVM, Liquid I/O to SmartNIC. The device under test is connected to the high-speed ports of the PktPump hardware. The PktPump hardware runs Blue Hat Soft developed custom firmware. Here is the typical deployment diagram for PktPump. Let's examine the main components of PktPump in detail. On the rightmost side, the DUT connects the host on a 10, 25, or 40 Gbps link to the PktPump hardware. This DUT could be a switch, a router, a NIC, or something of that sort. The PktPump hardware is deployed on this x86 64 box. It is the KVM Liquid I/O, which is Marvell Liquid I/O 2 NIC with special firmware that Blue Hat Soft designed and developed for packet crafting, traffic generation, and traffic syncing from the DUT. The drone runs on this host. The PktPump hardware is deployed on the host as well. The drone has to be run on the same physical box as the one that hosts the PktPump hardware. The GUI frontend, also known as the controller, can be run on a laptop or a workstation. It need not run on the same computer that hosts PktPump hardware. The GUI used for crafting packets, manipulating fields of the packets, creating sequences of packets, which is called flows, start and stop traffic generation, examine the statistics, etc. The controller connects to the drone over cloud using IP protocol. The GUI frontend is called the controller. The controller is based on a slightly modified version of Ostinato frontend. The controller runs on a laptop or a workstation. It is currently supported on Ubuntu, Red Hat, CentOS, and Scientific Linux. But it is based on Qt framework and is portable to MS Windows or Mac. As I mentioned already, it need not run on the same computer on which the backend drone runs, but it definitely can. When run on different machines, the controller connects the backend using IP sockets, the default port being 7878. It can be changed. The controller is a client for the backend drone. Um, Multiple controllers can connect to the same drone as well. The PktPump backend or the drone is also based on Ostinato, but it is heavily modified to interact with the hardware traffic generator. The drone interacts with the front end using sockets and protocol buffers and acts like a server to the front end. It interacts with the hardware using a kernel driver as well. Its functions include parsing messages from the front end, processing them, and to effectuate them on the hardware device. It collects information, status, statistics, etc. from the hardware device and sends the relevant information back to the controller for display as well. In addition, it updates and synchronizes different hardware states with the controller. The resource requirements for PktPump backend. The PktPump backend drone runs on CentOS 7 on x86-64 hardware. It runs on Red Hat Enterprise Linux 7, Scientific Linux 7, or any other Red Hat Enterprise Linux derivatives like CentOS. Currently, only x86-64 hardware platform is supported. The resource requirement for hosting the hardware and software backend is very low. We have successfully tested it on a 4 GB RAM Intel Core 2 Duo processor-based computer for dual 10G line rate traffic generation at 64 octet size. That's around 28.8 million packets per second on a Intel Core 2 Duo processor. We are very confident that the same rate can be achieved on a feeble Atom processor with a single lane PCI slot as well. For the PCI bandwidth requirement is held very low and highly optimized. The PktPump hardware is Marvell Technology Group's industry-proven high-performance liquid I/O 2 smart NICs without any hardware modifications. Currently, PktPump supports 40 Gbps, 25 Gbps, and dual-ported 10 Gbps hardware backends. The firmware design and development was carried out by Blue Hat Soft. The firmware is a bare metal executable optimized for high throughput. It uses advanced features offered by hardware like message passing architecture. We define it as a set of state machines bound together by timers and messages. PacketPump supports almost all possible network protocol packet formats. Some of them are 802.3, 802.1q, ARP, Address Resolution Protocol, or SNAP, Subnetwork Access Protocol, different types of IP tunneling, V4 over V6, V6 over V4, etc. UDP, ICMP V4 and V6, IGMP, and a large number of other protocols as well. Packets are crafted in the controller. Almost any field of the supported protocols can be modified using the controller GUI at runtime. Controller supports using ranges in many fields to fill them with data that decrements, increments, or is randomly ordered. One of the most important features is the ability to introduce erroneous packets, which are vital for testing the PHY, MAC, or driver capabilities of the DUT. For example, if the DUT hardware has the ability to drop the packets with sizes less than a specified packet size, the developer may be interested in programming a wrong value for an IP packet length and check how the DUT's processing engine behaves under different error cases. Thus, the packet generator's ability to order fields even to incorrect values becomes very important. PktPump driver and the hardware supports packet length on the wire up to 15,600 octets. The hardware uses nanosecond timers and provide microsecond resolution for actions like start, stop, etc. Well, now with all the explanations, this diagram should become a lot more clear. In the controller, that is either on the workstation or on a laptop, the user crafts packets. The metadata is transmitted over IP to the backend drone. The drone creates packets and manipulates the metadata to create timing information, messages, and modifications to the packets. The timing information, messages, and packets are sent to the hardware. The hardware receives the messages and the firmware processes them and take appropriate actions, like collecting the statistics, starting and stopping generating traffic, etc. This concludes the introduction to PktPump, the hardware packet generator. For any questions, comments, or inquiries, please feel free to contact us. Also, we got other videos introducing the crafting procedure of packets, sending them to DUT, receiving packets from DUT, creating flows and streams of packets, etc. Thanks for listening.